everyone, my name is Calliope Courtwright and I'm a current Cutler Center assistant and part of the class of 2023 at Babson. Today I'm going to be going over some basic Excel functionality, and a lot of the information contained in this course is from the Wall Street Prep Excel class. Wall Street Prep is a self-paced online class that teaches a lot of information needed for finance careers. The tuition can get kind of expensive, but if you are interested in learning more, Babson has a number of free subscriptions a year, so please email this email on the screen if you want to learn more. I'm going to start talking about some key keyboard shortcuts. Often Excel users who are more advanced won't use the trackpad or mouse when they're using Excel, but instead do so with the keyboard. So if you notice on any tab of Excel, if you strike the Alt key, all of the different tabs come up with different letter shortcuts, and you can hit those shortcuts to get into those functionality within Excel. So the functions that you use most often, you'll memorize the keyboard shortcuts for, and you can get to anything using just your keyboard and the Alt key. Some shortcuts that are used most often are listed here, so I encourage you to memorize these and any others that you tend to use a lot. In terms of proper formatting, a lot of times hard-coded values are put in blue in models, and calculated values are put in black, as can be seen on the screen. And there's also Excel's default formatting. So if you click Alt-HJ, this will bring you to some of their default formats. So for example, if I wanted to format this as an input, Alt-HJ, and I can scroll up to Excel's default for input. The biggest thing here is consistency. So if you use Excel's defaults, you should use them throughout your spreadsheet. And if you just use the blue and black rule, vice versa. So next I want to talk about conditional formatting. And there's a lot of things that you can do with conditional formatting. Basically, this means formatting a number based on, or formatting a cell based on the number that is in that cell. So to get to conditional formatting, you strike Alt-HL, and this will give you a bunch of different rules. The most common is highlight cell rules, so you can highlight cells that are greater than a specific value. So say I wanted to highlight cells that were greater than 30, and I can choose what I want to highlight them with as well. There are a lot of other things you can do within conditional formatting, including data bars, color scales, top-bottom rules, and icon sets. So feel free to play around with these and figure out what you can do and how they can help you with your models. Next, we'll be looking at lookup functions, which output a specific value in a table given certain inputs listed here. First is HLOOKUP, which looks horizontally in a table for a specific input and outputs that value. So in this case, we'll be looking horizontally in the table for week 1. Then you select the full table array. And you have to tell Excel how many rows to go down from the input that it found. So it found week 1. This is the first row, and we want it to go to the second row to find that for January. So you can see it outputted the right value that we wanted here. And if we were to go here and change this to week 2, Excel would automatically change the output once I recalculate the sheet. VLOOKUP is very similar. It tells Excel to look vertically within a table for a specific input and output that value. So in this case, we want Excel to look for January within this table. So you input the input value and the full table, and then you want to tell Excel how many columns over it has to go, in this case 2 to get to week 1. And then with VLOOKUP, you have to give it a 0 to say that you want an approximate match. So we get the same value here. And if we were to go in and change this to February, recalculate our worksheet, we would get the February week 1 revenue. Match makes these functions even better because it tells you the relative position of the value that you have to input for the amount to go over, the amount to go down, which makes it even more dynamic. So match on its own isn't much of a function, but compared with other lookup functions, it's very valuable. So we want match to give us the relative value of January. So we give it the lookup value. And then you want the table array. So just the one column wide table that has that input within it. And then you want to tell it that you want an exact match. And that will tell you that January is the second input within that horizontal, or that, sorry, within that vertical list. We can combine match with the offset function to make our formula even more dynamic. The first argument is a reference point, which we would use as the corner of our table. And we're going to tell Excel how many rows down to go and how many columns right to go to get to the value that we want. To find the number of rows to go down, we are going to use a match function to find this January within this column. It is important to start your column from one down relative to your reference point. And then our match type is exact match. Then we want to tell Excel from the offset function how many columns to go right. And use another match function. We want to find week 1. We want to find week 1 in this row here, and an exact match. And this will output the same value as we had before. And you notice that even if we change both outputs, these two won't work because they aren't completely dynamic, only on one dimension, but this offset match is completely dynamic. Index and match is also completely dynamic, and it's very similar. So the index function takes an entire array, and you tell Excel how many to go over and how many to go down and then over from that array. So we're going to use the match function to find the number of rows to go down. Just like we did with offset. The difference here is that you want to start with this corner value. And we are going to find the month within this column, an exact match. And we want to find another match function to find week 3 within this row and an exact match. So you can see it outputs the same value, and both of them are completely dynamic. You can see they changed to the same value, whereas these ones broke down when both of the dimensions were changed. Next, we'll be going over some popular finance formulas. One that you use a lot is NPV, and this outputs the net present value from a stream of cash flows. The first argument is your discount rate. Often it's the WACC. Then you're going to input your cash flows starting from 1 year from today. This is important because if you start from year 0, you'll get a value that doesn't equal the NPV. If you have a value at year 0, input that after your NPV function is closed, like this. XNPV is similar, except it assumes that your cash flows come at unequal increments of time. So as you can see, these dates aren't equally 1 year apart. So we have to use XNPV. The first input is your discount rate, then your value starting from year 1, and then you'll put your dates also starting from year 1. And then if you have a value today, as we do in this example, you add it outside of your XNPV function. IRR outputs the internal rate of return of a stream of cash flows. And with this, you actually start from year 0, so you can just input all of your values all together. The second argument is a guess argument, and it's optional. If you don't put it in, it will assume 10%, which works in most cases. So the internal rate of return is 11% for these cash flows, which is higher than the WACC at 10%, so this is a good investment. XIRR, similar to XNPV, is the same thing as IRR, but with an uneven distribution of cash flows in terms of time. You start with your values, just like you do in IRR, and then you put in your dates as well. Again, the guess is optional. And here you can see that the IRR is a little smaller because of the uneven distribution of cash flows. In problems related to bonds, you often have given information, but with some information not given to you. So you can use Excel formulas to find that information. The first is the present value. Here you can input a rate. This is the yield to maturity on the bond. The number of periods, then the payment, the coupon payment, and the future value. And this will output the present value. Present value is always outputted as a negative because it is something that the bondholder pays to get the bond. So in this case, it's $573.21. So I'm just going to hard code that for our next function. Next, I'll show you how to solve for the coupon payments. So that's the payment function. First input's the rate, then the number of periods, the present value. Again, this has to be inputted as a negative, and the future value. If you want to find the number of periods, it's the n per function. Put in the rate, then the payment, the present value as a negative, and the future value. And as you can see, you can do this for any of the inputs. For required return, it's the rate function versus the number of periods, the payment, the present value as a negative, and the future value. And then the par value is the FV function. You put in the rate, the number of periods, the payment, and the present value is negative. So given any amount of inputs, you can find the missing piece using these functions. Finally, we're going to talk about sensitivity analysis in the form of data tables. And these allow you to determine the impact that a given input has on your output. You can do these as one-way or two-way data tables. In a one-way data table, you define your range of values that you want to change your input to in a vertical list like this. So in this example, I want to figure out the impact that my growth rate has on my intrinsic valuation. My current growth rate in my model is 2.5%, so I want to test out a growth rate between these values. It's important to note that you can't link this middle value to your actual assumption in the model here, otherwise the data table will break down. So once you've hard-coded these values, you then add in the cell 1 over and 1 up from your range of values linked to the actual output within your model. So my output is here, and this number is based on all the numbers in this model leading to this number. Then you are going to highlight your whole table like this, press Alt-D-T, and in this case you want to just put the column input cell and put in where the variable is within your actual model, and press OK. If we go back down to our data table and hit F9 for our sheet, we can see that the intrinsic value will be these amounts under these different conditions here. So this shows us that given these changes in the perpetual growth rate, we will have these internal intrinsic valuations. We can also set this one-way data table up vertically. These are the same lists of assumptions in the range, and this is still linked to that same intrinsic valuation within the model. Again, we highlight the whole thing, press Alt-D-T, and in this case, we're going to put that 2.5% from the model in this row input cell. I'm going to hit F9 to recalculate my sheet. We can get the same values here, just in a little bit of a different format. Two-way data tables allow you to do the same thing, but test for two different variables at once. So to set these up, you define your ranges of outputs from one variable, or of inputs from one variable horizontally. This is the same as I did down here. and then you define another range for a different variable horizontally. This is my range for my discount rate, and this is for my growth rate. We are going to link in the corner of our data table the output of our model, the 72.54 that we've been using. This is the intrinsic value from my model, and we are going to highlight the entire table like this. Instead of using Alt-DT this time, I'm going to show you how to do this from the menu. You go to Data, What If Analysis, and Data Table. Our row input cell is the variable that we're changing on this top horizontal list here, and that is our discount rate, which in the model can be found here. And then our column input cell is what we're changing for our growth rate, which can be found here. That's what our range is for this. Press F9 to recalculate our worksheet. And this shows you the different range of values given different discount rates and different growth rates.